Hello students, welcome to Gangs of Toppers. In this video, we are actually covering the topic that is chapter 15, that is humidity. This is very interesting topic, okay. In this topic, we are actually going through the topic that is humidity, and after that, we will understand the meaning of relative humidity and the absolute humidity. And again, we can able to differentiate between the relative humidity and the absolute humidity. And after that, we are going to the topic that is condensation and the forms of condensation also, that is cloud, dew, frost, fog and the mist. And after that we will go through the topic that is precipitations, and in this way again that is the types of forms of precipitation, that is rain, snow and the hail. And after that the last topic is that is about the rainfall. Now we will go through the topic one by one. First one is about humidity. The moisture that is continuously enters and leaves the atmosphere, and when present in the air, it gives air a different character. Now, it is talking about that is moisture that is present in the air. It is actually enter and leaves the atmosphere. Now, look, this is a diagram that is about the water cycle. Okay, the water that is on the ground, this is on the ground as also in the sea. It actually gets evaporated. And again to form a condensation, and after that is condensation get precipitated and rainfall occurs. Okay, so from here we can conclude that the moisture continuously enters and leaves the atmosphere, and when present in air, now we are talking about this moisture when present in air, it gives a different characters. Let's take the process by which water vapor enters the atmosphere. Now we are talking about that the process by which water vapor enters in the atmosphere on heating is known as evaporation. Means what is evaporation? Means it is a process by which water vapor basically enters in the atmosphere on heating is called evaporation. Now we will study about the condensation, the process by which water vapors that is forms water droplets on cooling. Now we are talking about that when this water vapor basically enters in the atmosphere. Now we want to cool, means the process involved in cooling the process, that is water vapor into water molecules after cooling, and that process is not condensation. And about the precipitation, that the process by which the droplet falls to ground in liquid, solid or frozen form is known as precipitation. Okay, so we have covered the topic what is evaporation, what is condensation and what is precipitation. And what is humidity? The amount of water vapor that is present in the air is known as humidity. So we have come across the four term, that is about the evaporation, about the condensation, about the precipitation, and the last term is about the humidity. You can see in the diagram that is we are going through the topic. What is this? First one we get this topic, what is evaporation. Evaporation means that is the process involved or the process by which the water vapor basically enters in the atmosphere on heating, because this is suppose this is sea, and now we are actually increasing the temperature due to the sun. So due to increase in temperature, that is water is basically converted into water vapor, and it is going into the atmosphere. So the process by which that is water vapor enters into the atmosphere, that is on heating. Once again listen please, I am talking about the evaporation. Means what is evaporation? Means the process by which this water vapor basically enters into the atmosphere on heating is called as evaporation. Now what is condensation? Very easy. About the condensation, if you talk that, now what is this? It is the process by which this water vapor that is happened due to evaporation is going to form water droplets. It is going to form water droplets on cooling. Okay, then this is called condensation. Okay, and now if we talk about the precipitation, then precipitation means that the process by which the droplets formed, on the ground is called as a precipitation. So we have come through this three topic, that is what is evaporation, what is condensation and what is precipitation. And what is humidity? That is it is actually the amount of water vapor present in the atmosphere is known as humidity. Now we will talk about that what is total volume of water that is present. Next topic is water. Next topic is the total volume of water in the ocean and the sea is constant. Now it is obvious that the total amount of water that is present in the oceans and the continent and the atmosphere are constant. Okay, this is because that all the water that evaporates from the earth's surface bodies is eventually returned to it directly from the process of condensation, precipitation, and indirectly by the steam and overflows from the land surface. If we talk about it, means it is talking about the hydrological cycle. This paragraph is basically about the hydrological cycle. What is hydrological cycle? We have already studied that the water that is present on the ground, that is present on the leaves, is basically enters in the atmosphere by the process of evaporation and again condensation, and again by the precipitation is again enter into the atmosphere. So all the water that is on the atmosphere, or on the atmosphere, we can say that on the oceans and on the continent are basically constant. Okay. So here it is written that the total volume of water that is present in the oceans and the sea are constant. This is because all the water that evaporates from the earth's water bodies is eventually returned to it directly by the process of condensation and precipitation, and indirectly by the streams and overflow from the land surface. Okay, I think up to here is okay. And this line is very clear because what is there is a continuous exchange of water between the atmosphere and oceans and the continent through the process of evaporation, transpiration, condensation and precipitation. This is very important. Please remember that if we talk about the hydrological cycle, there is basically a continuous exchange of water between the atmosphere, oxygen and the continent through the process of what? Through the process involved here is evaporation, transpiration, condensation and precipitation. So we are talking that there is a continuous exchange of water between the atmosphere, oxygen and the continent. And what are the process involved? Here the process involved is evaporation, transpiration, condensation and the precipitation. The moisture in the atmosphere is derived from the water bodies. The moisture that is present in the atmosphere is basically coming from the water bodies. What is the process involved? That is through the evaporation, and also water that is present in the atmosphere, or moisture that is present in the atmosphere, is also coming from the plant through the process of what? Through the process of water. Say that is through the process of transpiration. Now, these evaporated water that is undergoes condensation and form cloud. Now, these evaporated water that is undergoes condensation and form cloud. Now, when their saturation is reached, now if we talk about the saturation, and the saturation reached, what is going to happen? The cloud actually give away the water in the form of precipitation. Means when the saturation reached, or when the cloud becomes heavy, it start falling down. It start falling down. Okay, and this process is in the form of precipitation. Now, if we talk that if the is very important point that since the total amount of moisture in the entire system remain constant, yes, obvious. Since the total amount of moisture that is present in the system is entire constant, system is constant, a balance is required between the evapotranspiration and precipitation. Now, if we talk that since we know that the total amount of moisture that is present in the entire system remains constant. If we talk about that, if we talk about this entire system, the total amount of moisture is constant. So there must be a balance required between the evapotranspiration and precipitation. Means we are talking that there must be this transpiration, the plant's evapotranspiration must be in balance with the precipitation, and the hydrological cycle maintain this balancing. He is going to maintain this balance. It is basically maintained by the water cycle. It is basically maintained by the water cycle. Now, vapor is the gaseous state of water. Now we are talking about one term that vapor is a gaseous state of water. Obvious, we know that a liquid, solid and gaseous. There are three states of matter, that is liquid, solid and gas. In similar way, vapor is the gaseous state of water. A certain amount of energy is required in order to change water into the water vapor. Yeah, it's very obvious that actually we are changing the phase, we are changing the water molecules into water vapor. So here we are actually changing the state of phase, we are actually changing the water molecules into gaseous form. So we need an extra energy. So we need an amount, or we need a certain amount of energy in order to change water into water vapor, and this amount of energy is called latent heat. We will study about it. And heating of water over oceans, lakes and rivers causes water to evaporate. Yeah, as we have already studied that if we are going to heat, means the heat that is coming from the sun is going to heat water on the oceans, on the lakes and the rivers, and cause water to evaporate. And it is one important term here. It is written that the generally see how many calories are required in order to heat. It requires, that is about 600 calories. It requires how many? That is about 600 calories in order to heat 1 gram of liquid water into vapor state. Now, please remember that how many calories of heat is required in order to change 1 gram of water into water vapor. It's very important that how many calories required in order to heat 1 gram of liquid water into or water state. Means we are talking about that if we have 600 calories of hot heat, then we are going to change the state of phase. We are going to change the liquid water into vapor water. How much gram? Only 1 gram. Okay. Now, heat loss, that is heat loss occurs during evaporation. Now, as we already studied that if you are talking about the evaporation, we are actually giving energy. So in this case actually heat loses. Okay, now heat passes into the water vapor in helium form. So yeah, it's obvious that actually if we are talking about the change of phase, we are talking about the change of phase, we are talking about water is converted into water vapor. So here actually there is a hidden energy. There is a hidden energy means the energy is required in which the water is converted into water vapor, in which water is converted to into water vapor, and this energy is actually a hidden energy. So we are talking the heat energy that is passes into water vapor in a hidden form, and it is known as hidden heat, latent heat. I think up to here it's okay. Now when the condensation occurs, this latent heat is released back into the atmosphere. Now, what energy, because according to the conservation of energy, we know that what energy is given, it is also released back. So, what amount of energy it has taken during conversion? During conversion means during the change of state of phase from vapor to water or water to vapor, there is a hidden energy. So when the condensation occurs, this latent energy or this latent heat is actually going to release back into the atmosphere and causing a slight rise in temperature. Very important. This is very important. Means when the condensation occurs, the latent heat energy, the means the watt energy, means you can say that 600 calories is going to release from 1 gram of water, from 1 gram of water. So when the so in this case we can say that a huge amount of energy is going to release back into the atmosphere, causing a slight rise in temperature. This is why during the rainy season one feels more heat than when the skies are clear. Now it is saying that this is why most of the people feel heat as compared to when the skies are clear. Now this point is very important that we are talking about the we are talking about which we are talking about the very important concept. We are talking about that the distribution of distribution of heat. In this case we will study about the low latitudes and about the equatorial region and about the high temperature and about the that is poles, or we talk about the tropical desert. One by one we will understand that. First understand what is about the tropical desert. In the tropical desert, the surrounded by the seas, evaporation is maximum because of high temperature and clear skies. Now if you see that in the tropical desert, if we talk about the tropical desert, it is basically surrounded by the seas. Suppose evaporation will be maximum. Why? Because there will be high temperature. Now very important, in tropical areas the temperature will be high, so evaporation will be maximum. And second point is that if we talk about the equatorial region, here the temperature, you know that in equatorial region sun or insolation we get throughout the year, and in this case we actually this tropical region actually the temperature of a tropical region is relatively low as compared to the tropical desert. Okay, and the last one is about the low latitudes. We know that in low latitudes it has relatively high temperature as compared to equatorial region. Means we are talking about this equatorial region and we are talking about the low latitudes. If we compare the equatorial region and the low latitudes, equatorial region will have a little less temperature as compared to low latitudes, because you know that in equatorial region water insulation is throughout the year, so water vapor is more, and if water vapor is more, then after 2 or 3 o'clock again due to precipitation rainfall will come. But if we talk about the low latitudes, it is relatively higher temperature and evaporation will be greater. Actually this paragraph is talking about the means distribution of humidity. Again I will make the diagram. This suppose this is a north pole, and this is a south pole. Okay, please understand properly. And this area is actually our equator region. Okay, so and this is our tropic of Cancer and this is our tropic of Capricorn. Okay, and this region basically called as tropical zone. Now here we know that here the temperature is low. Here the temperature low means here the humidity means what? Humidity that is present in the that is the amount of the moisture that is present in there will be high. But if you talk about this equatorial region, here the temperature is getting more. Still in this region, due to increase in temperature, humidity will be high. Okay, now if we talk about this low latitudes, here the temperature is also, as compared to this, temperature is here also relatively high. Why? We will see that in equatorial region, because due to high humidity, here due to condensation and precipitation, water will get after 2 o'clock. But in this region water is not happen, okay, that much. So this area that the temperature is relatively high as compared to the equatorial region. Okay, so if the temperature is high as compared to this area, we are comparing this equatorial region, then what is going to happen? Humidity will be high or low? Humidity will be low. Okay, or you can say that the relative humidity will be low. Okay, we will study one by one. Humidity, dry air promotes a greater evaporation. Now first topic, that it is clear that the factors favoring the evaporation are, first factors, that is about the humidity. Dry air promotes greater evaporation. Dry air promotes a greater evaporation. Yeah, it's obvious that dry air promotes a greater evaporation. Why? Because if you talk about the dry air, the intermolecular space between the molecules that is present in the dry air is greater. So if there is a space, means a space between the molecules is greater, means it has more capacity to absorb, it has the more capacity to absorb or to hold water vapor. It has the more capacity to hold water vapor than the humid air. I think it's okay now. Means we are talking about the dry air. Means what we are talking about the dry air, the intermolecular space between the molecules that is present in the dry air is greater. So what is going to happen? So the dry air can hold more. Dry air has a capacity, has more capacity to hold water than the humid air. Now our next point is that supply of heat. Our next point is about the supply of heat. The greater the heat, I mean the second one is that if we talk about the temperature, if the greater of heat, the water surface means if the temperature is increased, the above it, the greater will be the rate of evaporation. Means if the temperature is increased, the rate of evaporation will be also maximum. Means there is a direct relationship between the evaporation and the temperature. Means if the temperature is more, the rate of evaporation will be more. The rate of evaporation will be more. The third one point is that wind, about the wind. A strong wind, it's very common example that a strong wind promotes evaporation. Yeah, now it's also, there is a direct relationship between the wind and the evaporation. If there is a strong wind, then the rate of evaporation will be more. So the best example is that wet cloths dry more quickly on a windy day than when it is calm. Please remember this one. Now we'll talk about the humidity. When water is added to the atmosphere by the process of evaporation, it changes from liquid to gases. Now because we are adding water to water vapor in the atmosphere, so actually there is a changes of liquid to gases form, and the water vapor that is present in the air is called humidity. Then what is called humidity? The water vapor that is present in the atmosphere is called humidity. And now this will study that humidity is inversely proportional to heat, and the hotter the air, the more is the water vapor present in it. Now this is a very good concept. Okay, we are talking about that humidity is inversely proportional to heat. Okay, so let's understand that from the diagram. Now we are talking about that if the temperature increase, what is going to happen? It is written that the humidity is inversely proportional to heat. Humidity means when the temperature increases, the humidity is going to decrease. How? Suppose this is a diagram. We are talking that at 10 degrees Celsius, we are talking about the volume. This is a volume of air. Okay, at 10 degrees Celsius, we are taking this as a volume of air, and in this the actual amount of water vapor, means we are talking about this volume of air contains actual amount of water. Now what we are going to study, that is we are taking this as volume of air, and at 10 degrees Celsius the volume of air is this much. Now this volume of air actually contains actual amount. This contains the amount of water vapor. This contains amount of vapor, and this contains amount of vapor, and that is equal to the maximum amount of water vapor that it can hold. Means this volume of air can hold a maximum amount of how much? This much. Okay. and that is equal to the actual amount of water vapor that is present in this. Then here we will get, that is the relative humidity will get 100%. Okay, now we are going to increase. Now please understand one by one. We are talking about that we are taking at 10 degrees Celsius, the volume here is this much, and this contains water vapor that is equal to the maximum amount of water vapor that it can hold. And if this condition happen, this will be as 100%. Actually, one more point I have to write, that is now just remember this one, this diagram, that is we are talking about this volume where, so it contains the actual amount of water where it contains, suppose 10 gram, and 10 gram, suppose it contains 10 gram, and the maximum amount of water vapor it can hold 10 gram. The 10 divided by 10, how much it come? 10 divided by 10 into 100 means, once again I will say that this is the at 10 degrees Celsius we have taken this volume here, and this volume here contains how much gram? 10 gram, and this volume here contain maximum amount of water vapor, how much? That is 10 gram. Then we will from here we can, if we cut that, we will get 100%, means the relative humidity is how much? 100%. Okay, now if now we have taken this volume where, now we are going to increase the temperature, we are going to increase the temperature from 10 degrees Celsius to 20 degrees Celsius. What is going to happen? This volume here is going to increase. Why? Because due to increase in temperature, the intermolecular space between the molecules or between the air molecules is going to increase. So this volume here is going to increase. Why? Because of increase in temperature, because of increase in temperature. So this area is actually now already taken that actual amount of water per, how much that is, it was a 10 gram. Now suppose this because due to increase in the volume here, now the holding capacity or the maximum amount of water vapor that this volume here can hold is increased. Why? Because this area, the volume of that is increased. So earlier it was holding maximum, that is 10 gram. Now this volume here can hold how much? That is 20 or 30 gram. So suppose it hold 20 gram, then how much will come? That it will come 50. And similar way, suppose earlier it was 10 gram, and now the holding capacity of this molecule is going to increase. Suppose it is going to increase 40 gram, and we have only 10 gram, and here we have only 10 gram, and the maximum that is 20 gram. Means with increase in temperature, we have seen that with increase in temperature, that is water holding capacity of the molecules is going to increase. If the water holding capacity is going to increase, that is the maximum amount of water is going to increase, that is the denominator portion is going to increase, then what is going to happen? That is the relative humidity is going to decrease. Once again you see, that is we are with increase in temperature, that is the maximum amount of water vapor, or you can say that the holding capacity of water vapor is going to increase. That is the denominator part is going to increase. Then what is going to happen? That is our RS value is going to decrease. That is, this was actually saying in this topic, that is humidity is inversely proportional to heat, and that is hotter there, means if we are increasing the temperature, the more is the water vapor present in it. Why? Because the intermolecular space between the molecules is going to increase. When the atmospheric pressure is low, now if we take that, if the atmospheric pressure, just look this diagram, if the atmospheric pressure, if the temperature is low, what is going to happen? The relative humidity or water holding capacity of the molecules is going to decrease. Now we will study one by one, that is what is absolute humidity. What is absolute humidity? The amount of water vapor held by air at a certain temperature and volume is called absolute humidity. Now what is absolute humidity? It is actually the amount of water that is held by the hold by air or held by air at a certain temperature and a volume is called absolute humidity. Means in this actually we are talking about that what is absolute humidity. It will come as like this. Absolute humidity, or AH is equal to, that is amount of water vapor that is holding divided by, that is volume where we divided volume where. So what is the amount of vapor? It is taken in gram, and the volume where it is taken in centimeter cube. So what will the unit will come? That is gram per centimeter cube. Okay, so it is written that is the amount of water, that is a vapor held by air at a certain temperature and a volume is called absolute humidity. As absolute humidity is the mass or weight of a vapor per unit volume. You see, same, that is it is the amount or weight of vapor per unit volume where usually calculated in a gram per centimeter cube. Okay, now since the air rises up, absolute humidity may change now, because it is taken as a constant temperature. It is taken as a constant temperature. Now, if the air rises up, then the absolute humidity may change. Why? Because the volume of air is going to increase. If the volume of air is going to increase, then what is going? It will obvious means we are talking at a constant temperature the volume of air will be fixed. Now, with the rise in temperature or with the air that rises up, then what is going to happen? The volume of air is going to increase, then or going to change. Then what is it will affect on the absolute humidity. So, therefore, in weather calculation, absolute humidity is generally not taken into account. This is the limitation that due to rise in air, due to air rises up, absolute humidity is going to change. Why? Because the volume of air or the intermolecular space between the molecules, between the air molecules is going to increase. So, there is effect on the absolute humidity. So, it is in weather condition it is not taken into account. Now, second point is that about the relative humidity. What is the relative humidity? It is the ratio between the absolute humidity of a given mass of air divided by maximum amount of water that it can hold. Means this we have already talked about that relative humidity is equal to the actual amount of water vapor that the air can hold divided by the total amount of water vapor that the maximum amount of water vapor that this volume of air can hold. Okay. Then what is talking about that water vapor that it can hold at the same temperature is called relative humidity, and it is generally expressed as a percentage. It is generally expressed as percentage. The relative humidity is equal to actual amount divided by water holding capacity. We can say that is the actual amount of water vapor divided by maximum holding capacity. Maximum water holding capacity into 100 it come as a relative humidity. Now, one example is given that if the temperature of air masses is 25 degrees Celsius, if the temperature of air masses is 25 degrees Celsius and if its relative humidity is 60%. Now, I am saying that at 25 degrees Celsius the relative humidity is 60%, then it can still hold 40% more water vapor at the same temperature. Now, it is talking that if we are going to increase, it is saying that the relative humidity is how much 60%, and if the relative humidity is 60%, then still this air mass can hold how much 40% more water vapor at the same temperature before it comes saturated or relative humidity become 100%. Okay. Now it is saying that if how much it is 60%. Okay. So we can add means we can add 40% more water, 40% more water in order to become the relative humidity 100%. Okay. Means when the air becomes saturated, then it is not going to accept more water into the air. One more example it is given that if a sample of air, if this is a sample of air, if a sample of air hold 20 gram per centimeter cube at temperature how much 25 degrees Celsius, but the capacity to hold is 25 gram per centimeter cube, means it is saying that this is absolute humidity. So, saying that at 25 degrees Celsius it can hold how much gram? 20 gram, but the maximum holding capacity is up to 25 gram. So, the relative humidity from here we can find that 20 and the maximum how much it can hold, 25 into 100 it will be 80%. So, the relative humidity of air is about 80% at 25 degrees temperature. Now, relative humidity is going to increase with more water vapor in the atmosphere but decrease with reduction water vapor. Yes, because why? Because if we are going to increase, what we said that is humidity is going to increase or the relative humidity is going to increase with more water vapor. With more water vapor in the atmosphere, if more water vapor that is present in the atmosphere, then the relative humidity is going to increase. Okay. And the second point is that when the air is fully saturated, the relative humidity will be 100%. Obvious, because when the water vapor that is present in the air in the atmosphere is get fully saturated, means the relative humidity will be 100%. The saturated air will not hold any more water vapor. Now, if we talk about the saturated air, it is not going to hold more water at that temperature. Okay. And the dew point, what is called the dew point? The dew point is the temperature at which air gets fully saturated. What is dew point? Dew point is the temperature at which air gets fully saturated is called the dew point. Okay. Now we will study that relative humidity is the most essential characteristic of the climate. Now, what is studied? Relative humidity is the most important characteristic of what? Characteristic of climate. I think we have already studied this topic, that is there is an inverse relationship between the temperature and humidity. It means that it is inversely proportional to temperature. Now, From here we conclude that if if the temperature increases, then what is going to happen? If the temperature is going to humidity, then humidity is going to, or humidity capacity is going to increase. Humidity capacity is going to increase, and humidity capacity is going to increase. It means that RH is going to decrease. RH is going to decrease. Yes. Humidity capacity means what? Humidity capacity means what? That is water holding capacity or moisture latent capacity. Okay. It means what? That is air moisture retaining capacity. Humidity capacity means moisture retaining capacity. Once again listen please, if we are going to increase the temperature, then the humidity capacity or the moisture retaining capacity is going to increase. It means that if this is going to increase, means that we are increasing the denominator part, we are increasing the denominator part. If the denominator part is going to increase, then what is going to happen? That is the RH value is going to decrease. Okay. Now, and one more point we have already studied that when RH is 100%, when one more point we have already studied, when RH is 100%, then air is when RH become when RH is 100%, it means that the maximum, the water, actual amount of water vapor that is present in the volume here is equal to the maximum holding capacity. And if the air is saturated, means if when the RH is 100%, air gets saturated, means air gets saturated, here air gets saturated. If you say that what is saturated air, means when the relative humidity is 100%, then that is called, that means that air is saturated. And from here the condensation start. From here the condensation start. And what is dew point? The temperature at which this happens, the temperature at which air gets saturated is called the dew point. Is called the dew point. Okay. Now we will study about that, what are the factors that is affecting the relative humidity. What are the factors affecting the relative humidity? This is very best example. Okay. What are the factors that is affecting the relative humidity? First one is about the temperature with respect to what? First one is temperature. Now first one is about factors affecting the relative humidity. First one is about the temperature. As we have already studied is that the temperature has inverse relations with RH. If we are going to increase the temperature, then relative humidity is going to decrease. Second one is that about the altitude. About the altitude means, yeah, if with increase in altitude, there is a direct relationship between the relative humidity. If you are going to increase the altitude, it means that we are decreasing the temperature. It means that we are actually decreasing the temperature. It means that the relative humidity is going to increase. Now about the third one, that is latitudinal extent. Latitudinal. If we talk about that, this is our equator, and this is the low latitudes, and this is our south pole. So here you should remember that this low latitudes has more temperature as compared to the equatorial region. Please remember this one. Okay. So the low latitudes mean, this low latitude means what? Tropic Cancer and the tropic Capricorn region. This region actually has has more temperature than the equatorial, relatively more temperature than the equatorial region. So from here to here, if we are going to decrease in the temperature, then the relative humidity is going to increase. Okay. And in the same way here, just opposite of this, that is if you are going to go from this latitude to equatorial region, then what is going to happen here? The temperature is less, means relative humidity will be more. Okay. Now third one is that amount of water vapor. Yeah, because as we already studied that the relative humidity, that is depends on the water vapor that is present in the atmosphere. That is water vapor that is present in the atmosphere. So it is also depends upon the amount of water vapor present in the atmosphere. The last one is that distance from the sea. Yeah, relative humidity also depends on the sea, and if it is close to the sea, it means that here the water vapor that is will be more as compared to in the land, as compared to the continent. So if the water vapor that is present in the atmosphere is more, it means that relative humidity will be more. Now about the vegetation cover. Yeah, vegetation cover has important factors on the relative humidity. From the vegetation, actually from the evapotranspiration, water is actually evaporated from the plants and from the plants. So this transform through the transpiration, water actually from the plants is evaporated into the atmosphere, and if the atmosphere gets water through the vegetation, then it is going to increase. So we have actually how many factors? That is 6 factor. First one is about the temperature, second one is altitude, third one is about latitude, fourth one is about the amount of water vapor, fifth one is about the distance from the sea, and the sixth one is from the vegetation cover. Okay. Now we will study about the next topic in that second point is that our measurement of humidity. Second point is our measurement of humidity. The humidity of the atmosphere is measured with the help of a hygrometer. With the help of hygrometer, and also known as dry and wet bulb thermometer. So we are talking about this dry and the wet bulb thermometer. What is this? This is actually a measuring instrument, and through this we measure the humidity of the atmosphere. So what is this? This is the humidity of the atmosphere is measured with the help of hygrometer. With the help of hygrometer, and it is also known as dry and the wet bulb thermometer. In the dry and the wet bulb thermometer, a piece of wet cloth is tied. Now we are talking about this dry and wet bulb thermometer. In this actually, if let's just look this diagram. This is actually the first thermometer is a dry one, and the second one is a wet one. So the wet one is actually tied with a wet cloth. Tied with a wet cloth. So please go through this. In the dry and the wet bulb thermometer, a piece of wet cloth is tied around one bulb. Is tied around one bulb, and the other end of the bulb is dipped into a small container of the water, and a small container of water, and the rate of evaporation of water vapor from the wet bulb keeps the temperature of this bulb lower than the dry bulb. Now, actually, the wet bulb means what? That is the piece of wet cloth is basically tied around one bulb, and it is actually dipped into the water, into the small container, and the rate of evaporation. Now it is measured that the rate of evaporation of water vapor from the wet bulb keeps the temperature of this bulb lower than the dry bulb. Now due to wet, the temperature of the thermometer is going to what? Will we have different? If the temperature is low, then it will show the less temperature as compared to the dry bulb, and a difference in the temperature. Then a difference in the temperature between the two thermometer indicates the relative. Now the difference between these two, that is dry and the wet thermometer, indicates the relative humidity. Now saturated air will not allow evaporation. Now it is very important that the saturated air will not allow evaporation. Why? Because since the air is saturated, means since the air relative humidity 100%, it means that water holding capacity is no more, means it is already attained the maximum amount of water vapor. So if the saturated air will not allow evaporation, and in such case the temperature reading on both dry and the wet thermometer will have the same reading. So if there is a saturated air, then in this case the reading on both dry and the wet thermometer will be the same, and it means that the relative humidity is 100%. It means that the relative humidity is 100%. Now we'll talk some important topic about the relative humidity. Okay, what is relative humidity? The actual amount of water vapor present in the atmosphere is known as absolute humidity. What is absolute humidity? That is the actual amount of water vapor present in the atmosphere is known as absolute humidity. Second point is that it is the weight of water vapor per unit volume of air. How it is taken as? It is the weight of water vapor, that is it is the weight of water vapor present per unit volume of air, and it is expressed in the gram per centimeter cube. Now third point is that the absolute humidity differs from place to place on the surface of the earth. Yes, it will differ from place to place. Why? Because the weight of water vapor or the water vapor present in the atmosphere will be have different on different surface, or different on different place on the surface of the earth. The ability of water to hold water vapor, the ability to hold water, or the ability of air to hold water, that is depends entirely on the temperature. It's very important that the temperature, the holding capacity of water that is present in the volume of air actually depends on the temperature. All this has been already studied in this diagram. Now warm air can hold more moisture than the cool air. Very important data. Yeah, warm air can hold more moisture than the cool air. Why? Because in case of warm air, the intermolecular space between the molecules of air is more as compared to in cool air. Because warm air are actually what? It is light, and it is distributed, but in case of cold air it is densely compact. But in case of warm air, the intermolecular space between the molecules is actually away from each other. Now about the relative humidity, the percentage of the moisture, that is present in the atmosphere as compared to its full capacity at a given temperature is known as a relative humidity. Means now we have already studied that relative humidity is measured in percentage, and it is actually saying that the ratio of the moisture that is present in the atmosphere as compared to its full capacity at a given temperature is known as relative humidity. Now with the change in air temperature, the capacity to retain moisture is going to increase or decrease depending on the temperature. So it is saying that if you are going to increase the temperature, then the water holding capacity is going to increase or decrease. It will depends on the temperature. The third one, it is a greater over the oceans and least over the continent. Yes, relative humidity will be greater over the ocean than over the sea, because water vapor that is present over the ocean is more as compared to the continent. The last point is that relative humidity can either be of two ways, can be changed. Means it's talking that the relative humidity can be changed in two ways. First one is that by adding moisture through either evaporation. First one is saying that by adding moisture through the evaporation. First one, if the moisture is added by the evaporation, the relative humidity is going to increase or vice versa. Now it is saying that if the moisture that is present in the atmosphere is going to increase, it means that relative humidity is going to increase. Second point is that by changing the temperature, means if there is decrease in temperature, it means that what, that is decrease in the moisture holding capacity. It means that decrease in the moisture holding capacity, and it means that there is a water. If temperature decreases, it means that relative humidity is going to increase. Second point, that relative humidity determines the amount and the rate of evaporation, and hence its impact is relative humidity actually determines the amount and the rate of evaporation. What is going to determine the relative humidity? Relative humidity is going to basically determine the amount and the rate of evaporation. Means you can say that what is the use or significance of relative humidity? It is basically determine the amount and the rate of evaporation. Okay, so it is important for the climatic factor. Now last one is that air containing moisture to its full capacity at a given temperature is called to saturated. Means we have already studied that saturated air means if the relative humidity is 100%, it means that the water is it means that air is saturated. Now at this temperature, the air cannot hold any additional amount of moisture. Now at this temperature, that is the air cannot be hold any additional amount of moisture, and this condition is known as air gets saturated, and this is 100%. If the air have half the amount of moisture, now if we talk that if the air has half the amount of moisture that it can carry, then it means that there is unsaturated and the relative humidity is only 50%. Thank you. We will continue the cloud chapter, that this topic, that is condensation topic. We will continue this condensation topic in the next video. Thank you.